Good morning everybody. Myself Dr. Hena Pal, Department of Chemistry, Assistant Professor, Department of Chemistry, Krishna Chandra College, Hetampur, Birbhum, West Bengal. Today I will discuss about Borazine. Now, which is Borazine? Borazine is also known as Borazole. The structural formula of Borazine is B3N3H6. Borazines are actually colorless volatile liquid compound. In Borazine, the boron and nitrogen atoms are attached in alternate position, and all the boron and nitrogen atoms are attached with 6 hydrogen atoms. And we all know the structure of benzene. In benzene, 6 carbon atoms are attached with 6 hydrogen atoms in a similar manner as Borazine. So Borazine is isostructural with benzene, and Borazine is also isoelectronic with benzene. So Borazine is also known as inorganic benzene. Now we have to know the detailed structure of Borazine. Borazine has a planar hexagonal structure. It contains 6 member rings in which boron and nitrogen atoms are in alternate positions. All the boron and nitrogen atoms are sp2 hybridized. Each nitrogen atom has one lone pair of electrons, while each boron atom has empty p orbitals. So boron nitrogen bonds in Borazine is a dative bond. The sidewise overlap between the filled p orbitals of nitrogen atoms and the empty p orbital of boron atoms forms the boron-nitrogen bond. And due to the difference between the electronegativity of boron atoms and nitrogen atoms, all the boron and nitrogen bonds are polar bonds. That means the electron cloud in the boron B3N3 ring are partially delocalized. We see that the boron-nitrogen bond length in Borazine is equal to 1.44 angstrom, and this value is just between the calculated single boron-nitrogen bond length and the double boron-nitrogen bond length. That means B single bond N is 1.54 angstrom and double bond length is 1.36 angstroms, and the bond angles are equal to 120 degree. We see that Borazine and boron benzenes are isostructural and isoelectronic, but they have some differences. And what are the differences? Actually, the electron cloud of boron B3N3 ring of Borazine molecule is partially delocalized, while in case of benzene ring, the electron cloud is completely delocalized. Because in benzene, all the benzene ring, all the atoms are carbon atoms, the same atom, the carbon atom, and there is no electronegativity difference between the carbon atoms. So all the carbon-carbon bonds are non-polar bond, and for case of Borazine, all the boron-nitrogen bonds are polar bond. And because of the polarity of boron-nitrogen bonds in Borazine, Borazine undergoes addition reaction. Now how can we prepare Borazine? Borazine can be prepared in various methods. One is Stock Poland methods, in which diboron and ammonia is taken in 1:2 ratio and heated at almost 200 degrees centigrade, then we get Borazine. Another method is heating of boron trichloride with ammonium chloride at 140 degrees centigrade. Here chlorobenzene is used as solvent and iron as catalyst. First we get Cl3B3N3H3, and by reducing it with lithium borohydride we get Borazine. We also get Borazine by heating a mixture of lithium borohydride and ammonium chloride. Now the chemical properties of Borazine. Because of the bond polarity of boron-nitrogen bond, Borazine readily undergoes addition reactions, and the negative groups add to the boron atom through nucleophilic attack, and the electrophile attached to the nitrogen atom. So if HCl reacts with Borazine, then H plus electrophile attached to the nitrogen atom and the Cl minus, the negative part of the nucleophile, attached to the boron atom. And after addition reaction, all the boron nitrogen are sp3 hybridized. So BN ring loses its planarity and forms a saturated product. Borazine can also undergo hydrolysis reaction, and then it produces boric acid H3BO3 and ammonia and hydrogen. And this hydrolysis reaction is favored by the increase in temperature. Borazine is also pyrolyzed with heating almost above 340 degrees centigrade and produce B6N6H10 and B5N5H8. These are the actually boron nitrogen analogues of diphenyl and naphthalene. This can form adducts with methyl alcohol also, and this adduct also goes to pyrolysis reaction and forms beta-trimethoxyborazine. Borazine can also react with aniline and produced triaminoborine. So today till that much, and thank you to all of you.